Good morning all. Today we are gathered here to discuss a case study on GAN. So the topic for today is medical image enhancement using GAN. As we all know, GAN is nothing but the generative adversarial network, which consists of two neural networks, which is generator and discriminator. So generator tries to fool the discriminator, whereas the discriminator tries to evaluate whether it is a fake or the real image using a binary classification. Let's discuss the case study.
Hello everyone, I am Durga from the Department of BTech Artificial Intelligence and Data Science. Today we are going to present a case study on medical image enhancement, which is a part of deep learning. In hospitals, the doctor uses images like X-ray, MRI and CT scans, which is to diagnose the diseases. But many times the images are not clarity due to the low resolution, poor scanning condition and noises. This creates a major issue to diagnose diseases due to the image clarity. To solve this issue, the powerful AI technique called Generative Adversarial Network, which is also known as GAN, is applicable in this.
Hello everyone, myself Karpriya from the Department of AI and DS. Now I am going to explain what is GAN. GAN stands for Generative Adversarial Network. It is a type of neural network which is used in deep learning for generating realistic data like images, audios and videos. It have two components, generator and discriminator. Now I am going to tell about generators working. How the generator works. First, it creates a fake image that is as real as possible, and then it passes the image to the discriminator, fake images to the discriminator. The working of discriminator is comparing both the real image from the dataset and the fake images created by the generator and enhance the generator's working. Generator takes the random input with some noise and generate a fake image which is as real as the real images, and then the fake image created by generator is sent to the discriminator. Now the image created by the generator is passed to the discriminator. The discriminator compare the real data from the dataset and the image created by the generator and give feedback to the generator. This is helpful for creating a high quality and realistic image.
I am Harish. I am going to discuss about the types of enhancement. GAN can perform different types of improvements in medical imaging. The types are denoising, used to reduce noise from the image. Super resolution increases sharpness and quality of the image. Image reconstructor, used to reconstruct the damaged image parts. These are the things used to improve the detail.
Hello everyone, I am Gurukar from BTech Artificial Intelligence and Data Science. So now I am here to discuss about the real world case study scenario about this GAN, nothing but Generative Adversarial Neural Network. So before I am stepping on to the real world case study scenario, I would like to discuss shortly about what is meant by GAN. So GANs are nothing but Generative Adversarial Networks. These types of networks are part of deep learning, where used for generating images using its various techniques within it. So now let's step on to the real world case study scenario. There is an hospital where it receives various MRI scans. But here the problem is nothing but the diagnosed doctors and nurses find very hard to diagnose these images, which looks so blurred, not so sharp, and even lacks in certain visual kind of data. So to bridge this kind of problem, they thought of like bringing upon AI and deep learning techniques like introducing the generative adversarial networks named GAN. So how this bridges generative adversarial network bridges solution for this problem is nothing but we input the various kinds of blurred images to the network. The network what it does is nothing but first processes the blurred images. Using convolutional layer within the images, the network first extracts the information from the image. So next what it does is it processes the visual features and information. Then it passes to the layer known as discriminator layer. So what it does is nothing but this discriminator layer first discriminates the generated images network, like it's fake. So it's fake and it's not real, and till the enhanced image gets real and good and contrast, the discriminator just passes the images to the network. After an great and better visual looking real looking image, the network just generates an better image which looks sharp, good and realistic one. So now here the problem gets resolved by using this GAN, that is nothing but Generative Adversarial Network. So now the doctors using this GAN now can easily diagnose these various kinds of medical images and other medical data using this GAN to enhance the blurred images to an enhanced one, and just they can diagnose various kinds of data very good, sharp and clear. Thank you.
Myself Diwagar, I am going to talk about the real impact. After using a GAN, improved image clarity by using a large margin. No needed for repeated scans and better outcome and better diagnosis. This is especially useful in rural areas where the imaging devices are not available. GAN-based imaging makes healthcare efficient and more reliable for everyone.
Hi, I am Dinesh from Department of Artificial Intelligence and Data Science. I am going to talk about the challenges of GAN in medical imaging. Even though a GAN is powerful, it has some limitations. Large data sets needed. GAN may require many labeled medical image. Small data sets reduces the accuracy. High computational cost. Training needs powerful GPUs and long processing times. Training instability. Issue like mode collapse and non-convergence may occur. False details risk. GANs may artificial features leading to wrong diagnosis. Expert validation required. Outputs must be checked by the doctors. Cannot be replaced by the humans. Generalization issues. Model may fail on images from different scanners or hospitals. Ethical and legal concern. Patients' privacy and accountability are critical. Thank you.
Hi, I am Aravind. I am going to conclude the speech about GAN. GAN is advanced deep learning technique which makes the image better quality. In future, GAN can plays a key role in AI-driven medical systems. Doctor can make better decisions and improve the healthcare system.